Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So the minimum uncertainty in the energy is found from equation 28.2. So it says that delta E is greater than equal to h bar over delta t. And for the minimum value, we take h bar over delta t. And h bar is basically h over 2 pi, and that gives the value 1.055 times 10 to the power minus 34 joules times second. And we get this value to be 1.055 times 10 to the power 26 joules. But we need to convert it into electron volts. So we divide it by the number of joules we have in 1 electron volt. And we get this value to be 6.59 times 10 to the power minus 8 electron volt. So that's delta E. Now the transition energy can be found from the Bohr hydrogen atom energies, which is equation 27.15b, with Z equal to 1 for hydrogen. So we have, according to this equation, En is equal to negative 13.6 electron volt times Z square over N square. C is basically 1 here, and we can find the change in energy for a transition from 2 to 1 to be E1 minus E2, and this comes out to be 1 over 2 square minus 1 over 1 square, and Z is 1, so that just goes off, and we get this value to be positive 10.2 electron volt. Now for the ratio, we take del E over E2 minus E1, and this value comes out to be 6.46 times 10 to the power minus 9. Or if you want to approximate, this is 10 to the power minus 8. So the uncertainty in energy is a very small fraction of the actual transition energy. So let me just erase this sign because that can be a bit confusing, because this is the transition energy and I have denoted del E as the uncertainty in energy. Yeah. Now for the third part, we have to find the wavelength, and we use equation 27.4. So E is equal to h times f, and f, the frequency, is c over lambda. So we get the energy to be hc over lambda, and from here we can find the wavelength. And here, since we are finding the transition wavelength, E is basically the transition energy, or E2 minus E1. Now we solve it and we get this value to be, we get this value in units of uh, electron volt per, meter per electron volt. So we need to convert it into, we need to convert this energy into joules. So how do we do that? So we multiply it by how many joules we have in 1 electron volt. Now we have the energy in joules. Now we can apply this equation, Hc over E directly, and we get this value to be 1.22 times 10 to the power minus 7 meter. Now, if you don't convert it, your lambda will be your lambda will have the units to be meter joules per electron volt, and this is not a very nice unit. So it's better to convert this electron volt into joules. So they just cancel out, and you are left with meters. And this we can write as 122 nanometer. Now, taking the width in the line to be the uncertainty in the line's value based on the uncertainty in the energy, we will use equation 27.4 with binomial expansion. So this is the equation, is hc over lambda. So a slight change in wavelength will occur due to a slight change in energy, and this delta is basically the uncertainty over here that we calculated. So now we have to find the uncertainty in energy that can happen due to a slight change in energy. And we take this energy out, and we are left with this value, and this can be written as hc over E 1 plus del E over E to the power minus 1. So we have to be equal to, so hc over E is basically lambda, right, from here. So lambda times 1 plus del E over E to the power minus 1. So let me just repeat what I wrote there. And since here del E is very less than E, we can approximate it to be 1 minus del E over E. And this is called binomial expansion. Now let's expand it. So this will be lambda times del E over E. So lambda and lambda from both sides cancel out. So we are left with del lambda to be equal to negative lambda times del E over E. But we don't need to care about the sign. So because we just want the uncertainty, and it doesn't matter whether it's positive or negative. And we get this value to be, so we use the values of lambda and E and delta E from here. So E is basically, let me just write it. So E is basically E2 minus E1, the transition energy. And we see this value to be 8 times 10 to the power minus 7 nanometer. Remember to take care of the units. So whatever unit of lambda you are choosing, that should be the unit of del lambda. And remember that the unit of del E and E should be same. They should either be in electron volt, or they should both be in units of joule.